Good morning. My name is Rajdeep, and today's session is on Salesforce Einstein APIs with Golang and Scala. So, did you attend the API session yesterday? Yes? So, it was talking about the intent and sentiment APIs, right? So, my session focuses on the Vision APIs, which came out few months earlier, but we are going to learn how to access these APIs or use the APIs from languages like Golang and Scala. Anybody familiar with Golang or Scala as a language? Awesome. Aren't they cool? Yes. So before we get into the presentation, this is a mandatory slide we have to show. It basically says don't make any buying decisions based on, you know, what we discuss in this presentation. Please go to our website, look at the SKUs which are available, and use those to, buy whatever you want from the Salesforce services. Now let's do a quick recap on what exactly is predictive vision service, right? So we know that images are growing at a CAGR of around 9%. Today we are looking at about 1.2 terabytes of images on the web. And a lot of social conversations, whether these are in the context of an enterprise or they are in the context of a consumer use case, people are using images to talk to each other. Now, as a company, whose product might be being talked about on Twitter, Instagram, Facebook, how do you recognize the image and what people are talking about in the context of that image, right? So for that, you have to detect what the image is. Are they talking about me? For example, if I am Coca-Cola, are they talking about Coke? Which brand, which subcategory of Coke are they talking about? Are they talking about Pepsi? Are they comparing both the products, right? So for that, you need classifiers, right? All of us understand what are classifiers? Yes? So basically, see, it's called supervised learning. First, you train machines to recognize images and classify them into pre-existing labels. So Vision Service exposes pre-built classifiers. So we have generic image classifier, we have food classifier. And when you are in an enterprise use case, the generic classifiers might not be that useful. So you need to build your own classifiers. So that is where we provide you all the bells and whistles, the REST APIs, which you can use to build your own classifiers, right? So once you have these classifiers, the next important thing is how to use them in your application. So your application might be inside Salesforce, force.com. It might be an app on Heroku. It might be an app on AWS or Google Cloud or Azure, right? So that is where API is just an endpoint. How do you hit that endpoint? How do you authenticate against that endpoint? And once you have done that, how do you extract the relevant information from that endpoint? Now, let's go a little deeper. When we talk about vision service, any vision service in today's world is most probably built on neural networks, right? So what exactly is a neural network? We are trying to replicate the way our brain works. How our brain works, we have basically millions of neurons. They are called biological neurons inside our brain, which are connected to each other. So as you can see, we have like an input layer, a hidden layer, and output layer. So when you are a kid, right, an image is shown to you for the first time. You see that image, and your parent or somebody who's elder to you says, hey, this is a car, this is a truck. So that sound activates a few neurons in your brain. So the next time you see an image, you are able to say that a sound like car or truck can be associated with this image. So when somebody is telling you as a kid, so this is a truck or this is a car or this is pizza or this is something else. So the weights and biases get built into your brain. The same concept is taken, and we have something called as digital neurons. So we activate those digital neurons internally in predictive vision service. So these activations are basically called weight, W and B. Weight is how much weight you want to give to a particular trigger, to a particular shape in that image. And when hundreds and thousands of these neurons They are connected to each other. And what we do is, then we use that to build a model, right? So what exactly is a model in data science? Model is nothing but a very, very simple linear equation. So the equation which you see here, y cap equal to wx plus b. Can you guess what is x in this? It's the input, right? So when you want the classifier to tell you what is the label of this input, you basically input the binary array of that image, right? It could be a two-dimensional array, it could be a three-dimensional array. So when will it be three-dimensional? If you have a colored image. If it's a black and white image, it's going to be two-dimensional. And W and B is basically what the model is. So any machine learning algorithm across the world, whether you are using TensorFlow, you are using predictive vision service from Einstein, or using Theano, it's all about figuring out what are the weights and biases so that my output label is as close as to the real label. What is the output label in this case? The Y cap. The output label could be whether it's a Coke, whether it's a pizza, whether it's some other dish, and so on. So in this presentation, we are not going to do a deep dive on neural networks, but we are going to focus on what are the APIs we expose. So all this, whatever you saw on the previous slide, the wiring for, getting all the activation functions activated, determining weights and biases has been made very easy by our engineering teams. So what you need to do is, you just need to use our APIs to train your model, right, with your pre-existing data set. Once your model is trained, you use it to predict. So we are going to see how to use Golang and Scala to access these APIs and make those predictions. Now, Einstein Vision REST service exposes about 23 endpoints, right? So these 23 endpoints basically follow the traditional REST paradigm. You use the traditional HTTP verbs like get to get information, post if you want to update something. For example, if you want to create a new model, you'll use post, right? If you want to delete a data set, you'll use delete, and so on. So the most important thing to note here is, if you see the second last post, that is the first post you use to authenticate. So any API call which you make to Golang REST APIs, you have to have a API token. And this is the token which is called access token. This access token authenticates your call every time you make that call. So let's step back and look at the basic concepts of Vision APIs. So we have something called as a data set, right, as an entity in Vision service. So you need to basically use a pre-existing data set. For example, if you are trying to build your own food classifier, or you're trying to build a cold drink classifier, right? So you'll have, say, 100 images of Coke, 100 of Pepsi. You'll upload them to our service. So once you upload, it becomes a data set. So every data set in Vision service has an ID, it has a name, and it has the relevant data files. So once you have a data set, you can update the data set, you can delete the data set. And we'll see in the next slide, you'll use this data set to build your model. So what is the model in our case? The weights and biases, right? So you don't need to worry about what is the actual value of the weights and biases. All that is done internally by the Einstein Vision service. Now once you have your data set in place, next you'll make a REST API call to train the data set, and a model gets created. So the model itself is very small in size. Your data set might be few MBs, few GBs, depending on what is the use case you're looking at. But model is few KBs. And interesting thing is, once you have the model built, it gets persisted behind the scenes. Once you have a model in place, you can use it for months. But in the real life scenario, what will happen is, you might want to update the model every day, every few weeks, and so on. So we provide ability to update the model, retrain the model, and so on, right? And every model has an ID. It has model metrics. So in machine learning, the most important thing is how accurate is your model. So there are various kinds of accuracies. One is that validation accuracy, testing accuracy, and so on. And also there is something called as model learning curve. So what is a model learning curve? So it's a iterative process. So when you provide a data set and you train the model, so model does not become very accurate in first iteration itself. It goes through a few hundred iterations, and but as a developer, you don't need to worry about number of iterations. That all is fine-tuned by the Einstein team behind the scenes. Okay. Now, once you have your model in place, so you basically need to make a post call to this endpoint to get the prediction of the label. Okay. Obviously, you need to provide the access token and so on. Now, let's go to Golang. How do you do all this using Golang as an example? So why Golang? Go is an open source library which has been developed by a team at Google. They have been at it for about 6 to 7 years. It has become very, very popular. And the reason why it's so popular, it's very, very fast. It's statically linked. It's almost as fast as C. Now, a lot of people not only are building system APIs using Golang, they are also building web applications using Golang. So it's highly probable that you might end up in a situation where you have to use Golang, or you're using Golang application and you have to access Einstein, right? So there are two services which we have exposed in the Golang library which we have published. So first is the dataset APIs, second is the vision APIs. So dataset APIs take care of the life cycle of the dataset, and vision is for the prediction. So you can predict either a local image or a remote image. So let's look at how exactly you go about accessing Einstein APIs from Golang. The first thing is you have to build the HTTP client. This is a standard HTTP class which is already there in Golang. So we basically create an instance of this, right? And the next thing is that when we are passing this, we're sending the request to the appropriate endpoint, right, to create an HTTP connection. For example, in this case, we are trying to predict an image. We need to provide the model ID. Remember, every model has an ID, right? And also the sample location. Where exactly is this sample? It could be like on a remote HTTP URL, or it could be even a local file. So all that has to be written in the HTTP body. So once that has been written, the last step is you have to add the headers, right? HTTP headers, you have to add the access token. Access token is something which you can have a long-lived token or a short-lived token. What I've done in my case is for testing, I've a token, the life cycle is a few months. Once you have the token in place, you don't need to worry about it. But in production scenario, you might want to have a token which is not long-lived. Now, once your client is set and you have set the headers and the body, then you make the actual HTTP post call, right? So, and then you get a response. So all the responses in Einstein Vision APIs are JSON responses. So you have to basically parse the JSON and extract your information. So in this case, we are using basically one of the data structures within Golang. It's a custom data structure which I built to parse my JSON and show the results. Now we have our code in place. How do we compile and run it? In Golang, Go path is basically your working directory where all your project files are. So make sure you set up the appropriate Go path. Then you have to set the access key. So what I'm doing is in my library, I'm using this environment variable to find out what is the access key, and every developer will have a different access key, right? Obviously depending on the email you use and so on, and the private key you get. And then you basically call go run. So when you call go run, two things happen. The compilation and the runtime is also called. So the actual execution of the program happens. Now let us look at the demo quickly. So let me go to the Golang first. Okay, let me show you the source code of my example. So this is the source code. You can see that I have my model ID hard-coded here. This is the main function which gets called when you call go run. And you can see I'm getting the access key from the environment variable. This is the image I'm trying to classify. Let's look at what this image looks like. So what I've done is I just took 10 images of villas and apartments from one of the towns in India, and we basically trained our custom model, right? And now we are going to give a new image, and it's going to figure out what kind of building this model is. And rest of the code is very similar to what we saw in the slides. I mean, very simple, just make the appropriate call. Now I'm just going to run this. I've already, the go path set, I have access token in place. So you can see that it was able to verify that this is a villa with 99.9% probability. And this is kind of really powerful because I only use 20 images, right? So there is a concept in neural networks called inception. So what we use behind the scenes is something similar, so that with very small data sets, your accuracy levels are really, really high. It's kind of almost scary, how accurate this is. So let's look at how this looks like in Scala. So Scala is a slightly different kind of language as compared to Golang, right? Anyone, what is the main difference? Scala versus Golang? Anyone? No? Okay. So Scala is basically a functional programming language, right? So as compared to Golang, which is object-oriented, or it could be procedural as well. But Golang is not a functional programming language. So Scala you can use like similar to Python, or you can use it like a very powerful functional language where you have anonymous functions, lambda expressions, all these things you can move around. Now the interesting thing is it's JVM compatible. What does it mean? That all the nice libraries which you have in the Java world, like all the Apache libraries, all the other miscellaneous libraries, you could use as such in Scala. And it's as fast as Java. We know Python, it's cool, Ruby is cool, but they are not fast. You don't write them to write programs which can execute very fast. That is where Scala comes into picture. It's like similar to Python to program, but as fast as any JVM language. It's statically typed, so you don't have to worry about all the issues you come across in JavaScript, right? And Scala is becoming popular, especially because popular machine learning libraries like Apache Spark, they are written in Scala. It's still not there in terms of popularity as compared to R or Python for ML, but it's getting there. So similar to Golang, we have two services exposed in Scala. The first one is the data service, right? So to take care of all the life cycles. So this is not core Einstein Vision APIs. This is the library which I have written so that as a developer, your life becomes easier if you want to use with Scala. Second is the Vision service, which you will use to actually make the predictions, whether you are making a remote prediction, image is remote, or your image is local. And rest of the stuff is very similar. If you see all these API calls, you need to pass the access token, and you need to pass either the model ID or the URL of the image, depending on what exactly you're trying to do. So let's look at the same use case what we looked at in Golang. The first thing is you need to create a HTTP client. So for my library, I've used Apache HTTP client, which is a very popular library in Java world. The same thing works as such in Scala. And then you have to set the headers. So the headers are basically, the authorization access token. And also then you have to add the body. So what will you add the body? The model ID and the sample location. So if you see, the syntax is actually more readable as compared to Golang, because it's like a simpler syntax. And then we come to the real thing. We have our HTTP client in place. We have the body in place. We have the headers in place. Now we are going to make the actual HTTP call. So even before we make the call, I'm setting up all the objects so that I can handle the response and also parse the JSON. So now I actually make the execution call, the post call, HTTP. So once I've made the call, I get the response. So I'm using a library called JSON. Anybody is familiar with JSON? So it's a JSON parser from Google. It's been around for like 6, 7 years now. Very popular. There's another one called Jackson parser by Apache, but JSON is kind of little easier to use. So I'm using it to extract the information from my HTTP response. And then I'm just populating all the probabilities and the labels in a list and sending it to the client. Now, how do you compile and run Scala program? So in Scala, we have a build tool called SBT. It's called Simple Build Tool. So you can use it to compile as well as run the application. Obviously, similar to Golang, we have an access token environment variable. The same environment variable you have to use for Scala as well. And then this is how you actually run the program. Very simple. Let us look at the demo again. This time we are going to look at the Scala demo. Okay. So let me show you the Scala code. So you can see that this time I'm using a pre-built image classifier. If you remember in Golang sample, I was using a custom classifier, right? It was villas versus apartment. This time I'm going to use a pre-built classifier. I'm going to pass my image and it's going to predict what is the image. Let's look at the image we are going to pass. So this is the image. What is this? Anyone? This is an Indian dish called samosa, right? So let us see how intelligent my Einstein API is. So let me compile. So the first time you compile a Scala application, it's going to download all the libraries, right? Like Maven, if you know from the Java world. But here I have already compiled it once, so it's able to recompile very fast. Now let us run the actual application. So it actually opened the connection to Einstein APIs, and then it was able to show the results. Can you see it was able to predict with 96% probability that this is a samosa, right? So I'm sure Einstein team must have done some kind of learning that, okay, label samosa images to the actual label. But this is just a demo, right? It shows you that how to use a custom classifier, a pre-built classifier from Scala and Golang. Everything is clear? Cool. Okay. Oops. So let's go to the last few slides. So if you want to use these libraries, you can go to these URLs and either clone the library or fork it, modify it, and use whatever way you want to. And there, in addition to Scala and Golang, we have other wrappers available as well. So we have wrappers for Apex, we have wrappers for Java, and we also have wrappers for, I think, Swift. Okay. To summarize, Einstein Vision API is very easy to use from any programming language, but in this particular presentation, we saw how it can be used from Golang and Scala. Obviously, for any API call, you need an access token. I mean, just imagine if Golang and Scala is so easy, Java.NET would be even easier. So with this, we come to the end of this presentation. Any questions? Yeah. No. If you can come here.
My question is, in the case of an image with multiple objects, How does the response represent what everything in the image is and in the JSON? I mean, can it handle that, and how is it?
Yes, so we just released an object detection API as well in beta, and it's able to figure out so you have a JSON format where it will give you a list of objects in that particular image. But that was not being covered. Maybe next presentation I do at Dreamforce, we'll cover that as well. Yes.
You have shown how to use the classifier, but that is specific related to the language. Like for example, we have to write that thing in our Golang or whatever Scala it is. But what if we have to use it in a Python or a Node.js? So do you have a API exposed where we can mention the classifier and the images which it can take and let us know the result?
Okay, so the question is, what if we want to use the Vision APIs from, say, Python or .NET? So right now we don't have the libraries for Python or .NET, but we have the REST endpoints exposed. So you can write your own wrappers. For example, in Python, you could use URL lib or URL lib2 to write your but maybe in a few months we'll have wrappers out for those languages as well. But I mean, it's like safe harbor statement, forward looking statement. Any other question? Yes. No. So you can use Apex. So when you are trying to write a Scala application and you need to use Vision APIs. Yes. Say for example, if you are creating a Play application. So Play is a web framework in Scala. You could be using this particular library. Cool. So shall we stop here? If you have any more questions, I'll be hanging around in the mini hack area, and I'm also available here for a few minutes. Cool. Thank you. I- I'll have to check. Yes. Okay.